Hello there. We're now going to start reviewing 3.1.5, if I recall, which was linear equations. And how we're going to go over this is what I'll generally do for every time we do one of these lessons is I'm going to create a worksheet, and what we have is we have 10 problems on here, and then I created 2 graph problems that I would like you to work on, and then I will go over 2 of our own review graph problems. And so, just to start, we'll start over here. I want that to be negative. Okay, so we'll start over here. We'll start in the table. So, we have our first equation. We have our first equation, which is 3x plus 4y equals 12. And what we're going to do is we're going to want to isolate that y, which means we're going to have to subtract 3x from both sides. And that will leave us with 4y equals negative 3x plus 12. Now, the reason we do this is just we want to go back to that standard form, linear standard form, which is y equals mx plus b. Okay, and we still have an integer on our y value, so we're going to want to get rid of that. And how we isolate y in these instances is we divide both sides by 4. Divide by 4, divide by 4, and that will cancel out the 4's, and so this will cancel, and this will cancel. 4 divides 12 3 times, and then this will just turn into a fraction. And what that'll look like is you'll get y equals negative 3/4 x plus 3. Because again, 4 divides 12 3 times. And these don't divide, so we'll just turn into a fraction, and those cancel out in the y. And then we got our slope, which is m, which will be negative 3/4. And we have our y-intercept, which we'll refer to as b, but what we're going to call it in the future is we're going to call it y-intercept, which will be 3. Okay, and we'll do the first couple problems, and then I'll let you do the rest. And then I'll fill in the gaps, and we'll compare notes. So, kind of following on, we have our next equation. What we're going to want to do is isolate that y again. So we're going to add 2x to both sides. And that'll leave us with 7y. I'll create a better 7. 7y equals 2x plus 5. We're going to want to isolate that y again. So we'll isolate by dividing both sides by 7. And once again, in this case, the 7's all cancel out. And then these will divide each other again. So we got y equals 2/7 x plus 5/7. And filling in the gaps, our slope of m is going to be, again, the mx value, which in this case is 2/7. And then our y-intercept, or b, is the 5/7. 5/7. Okay. Now, what I'm going to do is I'm going to let you, actually, I'll solve number 3, and then I'll let you do 4 through 10. And then for 4 through 10, you'll pause the video, you'll do all the work, and then when you unpause it, I'll already have all the work done, and we can just continue on from there. So in this instance, we have negative y. What we can do to solve that is we add y on both sides, which will give us 5x equals 20 plus y. Now we want the y to be all alone over here on this side. And so what we're going to do is we're going to subtract 20 from both sides. and that will give us y equals 5x minus 20. And the reason I didn't do 5x minus 20 equals y is because it's the same thing regardless of how you do it. This y on either side is the exact same thing as if it were on this side. They're interchangeable as long as you keep the 20 and the 5 at their initial values, which is positive and negative. So next, we already have our equation, so this would just go here. And then our slope is going to be 5x, and our y-intercept is going to be negative 20. Okay, now here's the fun part. I'm going to zoom out, and what you're going to do is you're going to pause it, and I would like you to try 4 through 10. So please try. Okay, so now pause the video, and whenever you're done solving 4 through 10, come back and unpause the video. Really quickly, as I'm going through this, I noticed number 6 might come up as a harder question, and so I'm going to quickly do number 6 with you, and we'll go over that. So what we have going on in number 6 is we have 4 times x minus 2y, right? So what we're going to first want to do is take the 4 minus, multiplied by the x, 4 multiplied by the y, and that will give us 4x minus 8y equals 16. Now, what I did in this situation is I moved the 4x, and I went negative 4x over, or I subtracted 4x. And so on the other side, we have negative 8x equals negative 4x plus 16. And we have this negative 8y. Instead of moving everything on the right-hand side over and the 8 over, and instead of doing this flip-flop back and forth, what we can also do is when we have this negative 8y all alone over here, we can multiply the whole equation by negative 1. And what this does is it makes that 8y positive, and it makes it, you just multiply these by the reciprocal. So the negative 4 will turn into positive 4, and the positive 16 will turn into negative 16. Because again, what we're doing right here is we're just taking negative 1 to the 16, negative 1 to the 4, and then the negative 1 to the 8. And what this negative 1 does, basically in math, if you do negative 1, you're just getting rid of the negative sign, and you're adding 1 to any positive integers. So like negative 1 times negative 8 is positive 8y. Negative 1 times negative 4 is 4x. And then negative 1 times positive 16 is negative 16. And then from there we divide by 8 to isolate the y, and we get y equals 1/2 x. Now the reason we got 1/2 x is we have 4x being divided by 8, which if you notice that's 4/8, which is the same thing as 2/4, which is the same thing as 1/2. So just to simplify, because 4 is half of 8, it's easier to just do 1/2 instead of all the other fun stuff. So that's why I did 1/2 x minus 2, because the 6 and 18, or 8 goes into 16 twice. But from here, once again, pause the video and okay, continuing off where we last were, I left you to solve 4 through 10. So I left you to solve 4 through 10, and you can either have done the work or didn't. It's okay if you got lost in one of the equations and couldn't solve it, because here is my kind of like cheat sheet. I'll zoom in, and what you can do if you would like is you can sit here, you can pause the video, and you can kind of continue looking over what I did. And I know that I went over number 6 And I know another one that might cause a little conflict is 10. But just focus, just look at what I did in my notes, and yeah, but to kind of continue on with the lesson, what we're going to do is we're going to go over graphs. Yay! Our favorite thing ever. So what we're going to do is we have this equation, y equals 3/2 x plus 4. And we know that with graphs like this, we have coordinate points, which goes in the format of x comma y. And so if we wanted to follow our equation, we have y equals m of x plus b. B can also be called, the y-intercept point. And I call it the y-intercept point, and that's just kind of what it's called in math, but we all say b for the simplicity of it. But I would like you to start taking habit of saying y-intercept. And so what this means is we have this plus 4 right here. It's positive, and it's 4. So that means that on our y-axis, we're going to be going to 4. And just on the y-axis. So what that looks like is we'll have 0, 4, which I already put down here, but it'll look like that. And then from there, we can continue on with our equation. Now we have 3/2 x. Now if we look at 3/2 x, what this equation is saying is it is equal to y over x. And from what we know of y over x is x only ever goes kind of like left and right, and y only ever goes up and down. So if we follow that principle, we know that we're going to be going up 3 and over 2 on the for our slope, which is m. So let's do that real quick. And some people call this rise over run, where you rise 3 and you run 2. And that's kind of what I always called it. Some people call it steps. It's just kind of like whatever institution decides to do. But so what that'll look like is that. Ignore my messy handwriting and inaccuracy, but so we'll do that right here. So we started at 0, 4. We're going to go up 3. So 4, 1, 2, 3. And then we'll go over 2. So we went up 3. And then we went over 2. And that'll give us our next point, which is right here. And then from there, you can go ahead and sketch out our fancy line. Okay, it'll look like that. And that means we can just follow this trend, and we know that it'll reach somewhere around right here. But, so we're going to follow that same rise and run. We go up 3, and we go over 2. So, up 3, over 2. Because again, for our fraction over here, when we have 3/2 x, we're going to be moving on the x2, and we're going to be moving on the y3. Okay, so then we can, if you look at that, the dot is perfectly right there. So there you go. And one other way, this isn't like you have to do this, I just personally suggest this has helped out a lot with math, is so we started at 0, 4. So we started at 0, 4, which is right here. So we start, and you can say end is up here, but in reality, the line itself will go on forever, like it's infinite. But if you want to just say our endpoint that we solved is right here, then that's fine. And I'll put coordinate points for these real quick. This is 2, 7, and this one is 4, 10. And then this one we started at was 0, 4. So if we take these 3 coordinate points, we can tell one thing. For our y, the right side of the coordinates, our y, we went plus 3 and plus 3. We went plus 3y plus 3y. Because we went 4 to 7, and then 7 to 10, which is 3y, 3y. And then on our x-axis, we did kind of the same thing, but different. We went 0 to 2, and 2 to 4. So we went plus 2x plus 2x. Now, when we look back at our equation over on this side, we have 3 halves x, the 3 is y, and the 2 is x. And so what this kind of all insinuates is that if we take our beginning coordinate point, 0, 4, and we put our next point, which is 2, 7, we added 2x here, and we added 3y here, which is the exact same thing as this and that. So it's just all one trend. So what we can do then is we can predict our next point. We can say plus 2x, because we always add from the 2x right here. And so if we do plus 2x, and then if we take and we add 3y, which comes from right here, so plus 3y, we get 4, 10, which is the exact same as right here. So the way I just kind of showed you, where we take these coordinate points and we do the math, is it just kind of helps explain that you can start somewhere, your y-intercept or b, and then you can just add your fraction and you'll get the next points. So again, you add 2, you add 3, you get 7. You add 2, you get 4, you add 3, you get 10. And it's a really easy way to graph. And what it kind of like prohibits, or not prohibits, but what it kind of does is it makes it so you already know where your points are. So if you take it to a graph, you can just go to 4, and then you can go to 10, which is exactly right. No goodness, which is right here. It's just one other means of drawing a graph without having to draw a graph. I found it to be particularly helpful because then you could just take the points and you can sketch them out later. But if you want to follow this method, go for it. I support. I support any method. But I would say always draw your starting position. Always draw your starting position and always draw your ending position. And I would say after 2 dots, you're fine. Because after that, like, we know the next one's going to be here, and we know the next one's going to be here. So, like, there's no reason to keep drawing them out when we already know kind of where it's going to be going. But, yeah, this is my way to solve that. And I'll do my second one down here. So, this one, we're going to actually have to solve this equation. So what we're going to do is we're going to subtract 3x to the other side, so minus 3x minus 3x, and that gives us y equals negative 3x plus 6. Now, if you'd like, you can pause the video now, and you could go through and do the work, and then we could come back to it. So pause now and try to solve the work. We already gave the equation, so now just try to sketch it out based off what we did up right here. So I'll let you pause and use this as reference. Alrighty, okay, continuing on, we have y equals negative 3x plus 6. So, as noted before, this is b in our equation, y equals m of x plus b, and b is also called the y-intercept. So, and y-intercept means that it'll be always 0 on x and we'll be moving on the y-axis. And so since we got 6 here, we know our starting dot will be at 0, comma 6. And so we could go on our graph up here, over here to the side, and we could quickly put a dot on 0, 6. Now, we are going to go over to the 3x over here, and we talked about this before, but whenever we have whole numbers like 3, 2, 7, 8, 13, one good method or habit is just to put a 1 over it, or under it. Because negative 3 over 1 is the same thing as negative 3, but when we get into graphing, we get negative 3 over 1, and as we remember before, we have y over x, which means we're going, and because we have a negative sign right here, we're going to be going downwards, and we have 3, which is on the y-axis, and y only ever goes up and down, so we're going to be going down 3, and we'll be going over 1. Down 3 over 1. And that will be our trend. So if we go over to our fancy little graph right here, we start at 6. We're going to go down 3. 1, 2, 3. And then we're going to be going over 1. 1. And we could put a dot right here. So we went down 3. Oh, sorry. Down 3 because we had negative 3. So 6 minus 3, we ended up at 3. And then we went over 1. And we got this. And I'll draw this on the other side. So minus 3. Okay. Okay. Sorry about that. So when we look at this graph, we went down 3 because we have negative 3. And we went over 1. What is going on, computer? Okay. So let's take our golden line, our orange, and let's just draw our fancy line. Boom. And so if we can follow this trend, we could go back down 3. 1, 2, 3. Then we could go over 1. And we could put another dot here. So another dot. And we can go here to here. I'm going to try to... Okay. Now, we did the same thing here. We went down 3. And we went over 1. 1. And the reason we went down is because we have a negative 3. And so we have already drafted our whole graph right here. We can keep going, but it's unnecessary. So we're going to draw our start. So let me go to a different color. We'll go here. So, oh my goodness. This was the start. Was this top graph, or this dot. So start. And then we ended here. And then we have our midpoint. And let's draw coordinate points. So we started at 0, 6. And then we went down to 1, 3. Yep. 1, 3. And then we ended off at 2, 0. 2, 0. And so what we can do is what we did before. We'll take our points. So we had 0, 6. Whoa. 0, 6. 1, 3. 2, 0. And what we can look at is we're going down minus 3, minus 3, plus 1, plus 1. And if we look, we have negative 3 on our y-axis, negative 3y over 1x, which is the exact same thing as that. exact same thing. So we have now officially finished our second graph in our second equation. So now what I would like you to do is up here, I have created two graphs for you, and I have two equations. What I'd like you to do is I would like you to solve the equation, both of them. They both need to be solved. And then I would like you to graph it out over here. And you'll have to draw your own graph, but I would like you to just sketch your own graph, and then I will only do the bottom one. I'll do the bottom one for you, but the top one I want you to do all on your own. So I'll put a note that this is just you, and then I will assist for this one. Okay. So what I would like you to do is what we've been doing before, and I would like you to pause it. I will do the work for the second one, but I want you to do both these for me, okay? So right here, pause it. Okay. So now that you've already done the work for the top and the bottom, I will quickly do the work down below. So we're going to solve the equation by adding 6x so we can isolate our y plus 6x. We're left with 2y equals 6x plus 3. And then we're going to want to isolate that y. We'll do that. And then so divide by 2, and what we're left with is y equals 3x plus 3 halves. Now 3 halves is the same thing as 1.5. So what we're going to do then, because we have 1.5, yeah, or it's similar to 1.5. I'll do that. 1.5 is the exact same thing, but I'll do it in fraction form. So this is going to be a little awkward, and that's why this one's going to be a little harder than the other one, is because we have this fraction for our b. So how that'll work when we have a fraction for b. So again, our equation is y equals 3x plus 1 1/2. And this is our b, and this is our m of x, which we remembered that for whole numbers, like 3x, we're going to put it over 1. So what we actually have is y equals 3 over 1, x. I'll draw that better. Wow. X. Okay, so what this means when we have 1 1/2 is we're just going to go to our graph. We're going to go to 1 and 2, and we have to go to the middle, so we're going to put a dot right in the middle. Right in the middle. Okay, so this point is 0, 1 1/2. And then we're going to follow our steps as we did before, and we're going to go up 3. So 1, 2, 3 from 1 1/2, which is 4 1/2. And we're going to go over 2. Or we're going to go over 1. So we went up 3, and we went over 1. And so we got our second point, which is right here. And I'll have to draw the up 3 on this. So we went up 3. And the reason we went up is because our x right here is positive. So if we follow this trend, we have to go up another 3. So 4 1/2 turns into 7 1/2. And we have to go back over 1. So I'm trying to get a straight line. Okay. So we over 1 and back up 3. We put our second dot right here. Now we can just follow our fancy line. And look at that. We have steps and everything all sketched and graphed out. Now we'll just quickly go back over and do our whole gig. So we started at 0, 1.5. We went up 3 and over 1. So we went 2. This point is 1 and 4.5. And then we went over 1 again, which is 2. And we went up another 3, which is 7 and 1/2. Okay. If you got something like that, nice. But let me draw it down over here. So we started at 0, 1.5, and then we ended up at 1, 4, wow, 4.5, and then 2, 7.5. Yeah. Which if we look, we're adding 3 plus 3 plus 3 plus 1 plus 1, and this is on the x and this is the y. So we're adding plus 3y and plus 1x. And if we look back at our equation right here, we have 3y over 1x right here. And so it's just kind of like saying, instead of having to draw this all, you could just add 3 plus 3 and plus 1 to your coordinate points. Okay, and then I'm going to assume you had done this top one, but I'll just give you a rough estimate. It will look like, I may not be accurate because I'm just rough guessing, but you're going to start at 4. You're going to go up 2 and over 3. I said I was going to let you do this, but we'll call it being kind. We went up 2, and then we went over 3. And then we got it out right here. Oh. And then we went up 2. We went back over 3. And that'll give us this line from here to here. Stop. And we stopped at 5 comma or 6. I meant 6. We stopped at 6 comma 8. And then yeah, and then we stopped here at 3 comma 6, and then here is 0, 4. We added 2y every time, so plus 2y plus 2y, and then on this side we added plus 3x. Plus 3x, because our main equation is y equals 2/3 x plus 4. So, over 3. So, up to 3, up to 3. Okay, there is, I said I wouldn't do it, but there you go. But there's our lesson on, I think, 3.1.5, or just in general, this is our linear equations worksheet. So we'll leave it off there, and we'll reconvene next time.